Okay, today we are taking notes on atoms, elements, compounds, mixtures. So you should have already written down your learning target today, which is I can identify the parts of an atom. And we are on page 27. Okay, the title of our notes, again, atoms, elements, compounds, and mixtures. Okay, the first thing we're going to talk about today are atoms. And atoms are the smallest unit of matter that still acts like that substance. Okay? And there are three subatomic particles that we are going to talk about. Right? They are protons, neutrons, and electrons. Protons are going to have a positive charge. And they are going to be found in the nucleus of an atom. Neutrons are neutral, which means they have no charge. And they also are going to be in the nucleus with the protons. And electrons are going to have a negative charge. And these guys are going to be found orbiting the nucleus. And you might also hear that called the electron cloud. Okay, so if we were to draw a picture of an atom, I'm going to keep mine kind of small so all of our notes fit. We've got protons and neutrons in the middle, and around them are going to be electrons orbiting in the cloud, electron cloud, or in the orbits. Okay. So we've got a nucleus with protons and neutrons. And then these are the orbits. And that's where you will find the negatively charged electrons. Okay. Next, we'll talk about elements. Super fun. Elements. So when we're talking about elements, we're talking about like hydrogen and helium, carbon, oxygen, gold, silver. And all of the atoms in an element are going to have the exact same number of protons. If you change the number of protons, you're changing that element. So chemically, elements are the purest substance, right? If you have all these gold atoms, you can't go smaller than a gold atom and you'll have something different than gold. The atom is as small as you can go, where it still looks like that element that you started with. So chemically, the purest substances. And they're all found on the periodic table. If you look in the back corner of my room, you will see a periodic table. You all have a periodic table in your planner. Pull out your planners. Look for it. Right now, it is on page 125 in your planner. And I will tell you that there's another one in there, but I'm not going to tell you what page number, and I'll give you a sticker next class if you find it. Okay, so there's the periodic table. Right, so we've got all of these different elements. All of them have an atomic symbol. They all have two different numbers we're going to talk about in just a second. A lot of their names, like iron, for example, is Fe, comes from its Latin root, which is ferrous. So that's why some of them have funny letters. If they do have two letters, the second one is always lowercase. The first one's always going to be uppercase, and that helps you know if it's a new element. Okay, so right now, choose your favorite element on the periodic table, and you are going to copy down a periodic table square for that element, or you can just do mine with me. I'm going to choose carbon. Okay, so carbon has a big C. It is carbon. At the top, carbon has a little number 6. And on the bottom, it's got a 12.01. We're going to talk about what all of those things mean. Okay, that little number at the top is the atomic number. The atomic number tells us the number of protons in that element. Remember, I just said they have the same number of protons? So every carbon atom has 6 protons. If it has 7 protons, it's not going to be carbon anymore. It's going to be nitrogen. See that in your periodic table? So the atomic number is the number of protons. And it's the smaller number. Okay, each of the elements also has an atomic symbol. The atomic symbol are just the letters used to identify those elements. Makes life easier, especially when we're talking about bigger molecules like glucose is C6H12O6. It's easier to write C6H12O6 as opposed to 6 carbons, 12 hydrogens, and 6 oxygens. So that's why we use atomic symbols. And finally, the last thing that you will find on your periodic table square is this other number at the bottom. This number is the atomic mass. And the atomic mass equals the number of protons plus the number of neutrons. And what is kind of cool, right? Like, so it's not that there's 0.01 neutrons in carbon, it's that most carbons have 6 well, all carbon has 6 protons and then 6 neutrons. Sometimes you will find a carbon with 7 neutrons, not very often, and that's where that 0.01 comes from. It's an average of the number of neutrons found in nature. And next, we're going to talk about compounds. Compounds are 2 or more elements that are chemically bonded together. So a common compound in your life is probably water. Most of you know water is H2O, which means, so this little 2 is talking about the number of hydrogens. There are 2 hydrogens, and there's no number after the oxygen, so it's just 1 oxygen. Glucose, we already talked about it, we'll talk about it again. Glucose, C6H12O6. These numbers again talk about the element that they follow. So we would have 6 carbon, 12 hydrogen, and 6 oxygen. And see how much easier it is to write C6H12O6 instead of all of these words written out? That's why we use atomic symbols. All right, and the last thing in our notes today is going to be mixtures. Sorry, whoa. Okay. So mixtures, we'll make blue mixtures. And mixtures are combinations of elements and or compounds that are not bonded together. Combination of elements and or compounds that are not chemically bonded. Right, so they can be separated out. The air that you breathe is a mixture. It's a mixture of oxygen and nitrogen, carbon dioxide, probably some water vapor, probably some dust, probably some dead skin cells from inside your mask. Okay, so your air is a mixture. Salt water is another mixture, right? You dissolved sugar in water in that lab. Salt water is the same. It's NaCl and it's H2O. Okay, so we could draw a cup of salt water. And you would have NaCl. This is what salt looks like. It's 1 sodium and 1 chlorine bonded together. And you'd also have H2O. H2O is 1 oxygen and 2 hydrogen. And it looks like Mickey Mouse. Okay, so those are our notes for today. Next, you're going to be watching a video about just how small an atom is, and then we're going to do a PhET simulation on building atoms.